Hello, and welcome to 5 Minute Math. Today we are looking at the sixth grade concept of triangles. This is standard 6.8a in the great state of Texas, and we are using item number 31 of the 2025 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. All right, so we've got four different sets of angles. We're looking to see simply which ones could be the measures of a triangle. Now, what do we know about triangles? We need to know that a triangle has a set of degrees that the interior angles always add up to. And if you can't remember that, my suggestion is to always think, how can we remember? The easiest way to make a triangle? Well, start with a quadrilateral. Most of us can remember either a rectangle or a square. And if you can't remember how many degrees are in a quadrilateral, draw a rectangle or square. And I'm drawing it specifically because rectangles and squares have four right angles. And so even if we might not remember how many degrees are in a triangle, we can typically calculate how many degrees are in a rectangle or square because we know we've got four square corners, right? The right angle is exactly 90 degrees. That's the one thing we need to remember. Right angle is 90 degrees. And so what we have in a quadrilateral is we've got four sets of 90. Now, it also works for parallelogram, trapezoid, but then those angles are all over the place. Think of a square or think of a rectangle. Either way you look at it, a quadrilateral has 360 degrees. Now, why in the world are we starting with a quadrilateral? Well, this is if you can't remember how many degrees are in a triangle. We start with here, and we think you can take any quadrilateral, draw a diagonal line, and look what you make. You make two equal triangles. And it works, like I said, whether we do a rhombus, whether we do a parallelogram like this, and whether we do a trapezoid. Each of these have 360 degrees because that's, by definition, how many degrees are in a quadrilateral, a four-sided polygon. And if you take any of these shapes and draw a line like this, you are going to get two equal triangles like this. Okay? Now, they're going to be equal triangles if we have just regular polygons like this. Sometimes you might be able to make one, and the triangles aren't exactly equal, but the angle measures are always going to be equal. So think about it like this. If we take our 360 and we cut it in half, any of these, take our 360 and cut it in half, what you're going to get is you're going to get each half. And that's what we're looking for. That's how much is in a triangle. So let's take our 360 and let's cut it in half, do a little division, and what you're going to see is not 18, we've got to bring that 0 down to get one more, 180. 180 times 2 equals 360. So how many degrees are in a triangle? Any triangle. It's not 360, it's 360 divided by 2 because each quadrilateral can be turned into two different triangles. Just remember this 180. So when it says which set of measures could be the angle of measures, we're looking for the sum. Just add. Which set of measures, and they didn't say sum, there's no clue here that says you need to add, so that's the one word we need to supply into this word, into this problem is we need the sum. This is the triangle sum theorem letting us know that there are 180 degrees in any triangle. And if we add these, well, this is going to be 140. This is going to be 360. This would work for a quadrilateral B. 45, 45, 45 is 135. And then only D works. So that's what we're looking for, 180, because we know that each triangle, the sum of the interior angles is always going to be 180 degrees. Our answer is D.